analyzing categorical data in bar graphs. So let's check this out. We have this bar graph here, candidates at the bottom, number of votes going along the y-axis there, and it says calculate the percentage of total votes for boys in the bar graph. All right, so what was the percentage of total votes for the boys? All right, well, before we do this, they give this in the numbers, each Andrew, Becky, Derek, Dora, Miguel, and Trisha. We have all the votes that they tallied for 7th grade president. So we need a total. If you remember, we always have our percent over 100, and then our part to whole. And then when we remember to solve, it is our triangle that we draw here with the part at the top, the percent right there, and then we put whole right there, and then it's division and multiplication. Fix that a little bit, and multiplication to help us when we solve. So we need to total up all the votes first. This is just going to be counting. We don't need to get all these percent part whole just yet. So let's do Andrew here. It looks like he got 75 votes. Becky got 105 votes. Derek, it looks like, pulled 135 votes. It looks like Dora here is 150. It looks like Miguel got 90, and then Trisha with 120. And so we need to add all these up and get a total here. And I'm going to go ahead and just tell you what it is. I worked it out beforehand so we don't have to waste time doing the adding, but you should get 675. So it should be 675 total votes. So I'm going to back up here, and the total of votes for all of the candidates was 675. So what that actually gives us is the whole that we should have, 675. We know our percent will be 100. Now we want to figure out what the total number of votes percent-wise, what the percentage of votes was for the boys. So let's go ahead and isolate the boys here. So Andrew, Derek, and then Miguel will be the ones we look for. So Andrew got his 75 votes, Derek got his 135, and then Miguel got 90. So 75, 135, and 90. And I believe if you add that up correctly, the part that they received was 300. So we're actually looking for the percent. The percent is our unknown. So we got 300 out of 675. So when we are looking for the percent, we can kind of shade it out there. We have the part divided by the whole. That's exactly how we'll do that. So I'll go back and clear that out. So the part is 300, just like that. And we're just going to divide by 675. And we're going to get a decimal, obviously, because 675 doesn't go into 300. So we do a point here, and then we can solve real quick. And actually, I'm going to come back, make this a little bit more room just because I know what's going to happen here. We're going to make it a little smaller. Let's do 675. Sorry guys, 300. Alright, that should help us. Point. So 675 does not go into 330 or 300. It does go into 3,000. So we can put a 3,000 there, and it goes into 3,000. I think it's about 4 times when we get that. So when we put 4, we get a 4 right there. 675 times 4, when we do that, 2,700. So when we subtract, borrow here, 10 is going to give me 300. And then I bring down another one to get 3,000. But again, it's going to go in 4. I'm going to kind of get this repeating 4. So we could round this to the nearest hundredth, basically, and say, instead of getting 0.44, which is going to keep repeating, we can just kind of round this here to 45 and say 0.45. And then we move the decimal 2 places. 1, 2. The answer is 45%. So the boys basically got 45% of the votes, a little under half of the votes for 7th grade president. So here we were just solving for the percent, but we pulled the total off, and then that was our whole. Then we looked for the part. We were actually looking for divide the part by the whole. Don't forget your triangle here. And then you can solve for the percent by turning the answer, which is a decimal, into the percent. So give this one a shot. You can try it, you can pause it, and then unpause it and see how you do. It says the students in a class were asked which hand they preferred to use for writing. Bar graph shows the results of that. Of the students who had a preference, what percent chose the left hand? Okay. And then it says find the total number of students who had a preference. So kind of got two things going on here. What I'd like you to see is the ones who had a preference. I want you to look at this right here. Two-part question. Let's look at that. Don't worry about that one just yet. How many had a preference? You can pause it, figure that out, unpause it, and see how you did. So remember, we're looking for how many had a preference here. So we need to kind of put our numbers together. Left hand, we know left was 6 right there. Right is 18. So together, that's 24. And then no preference looks like it's about 1. Doesn't look like it goes quite halfway, which would be 1.5 or 2. So we're going to say no preference is 1. So the total, when we look at this, we have our percent over 100 part whole. And when we fill this out, we need to find the percent. So that's going to be empty at the top, over 100. The part is 24. The whole is 25. So in order to solve this, we need to, if you remember our triangle right here, if we're looking for the percent, we divide the part divided by the whole. And so the part is 24. We're going to divide by 25. And then see if we can get our answer. I'm going to make it 0.0. Keep our decimal in place. 25 is not going to go into 2 or 24, but it does go into 240. And I believe if you divide that by 25, it's about 9 times, because 9 times 25 should be 225. And when you subtract here, we can borrow to make that a 3. Put that there, that's a 5. We get 15, but we can bring down a 0 to make 150. And then 25 goes into 150 6 times evenly. It's 150. So it's 0.96, which if you turn the decimal into a percent, 1, 2 places, the answer should equal 96%. So 96% of the students had a preference when they were writing.